Okay, good afternoon, everyone. Welcome to Sustainable Horizons webinar series. My name is Yaqing Shu, the managing editor of Sustainable Horizons. I'm thrilled to be your host for today's presentation. Before the presentation, please allow me to introduce today's speaker, Professor Atilla Incecik. Professor Incecik is the editor-in-chief of Ocean Engineering. He is a professor of offshore engineering at the University of Strathclyde, Glasgow. During the last 16 years, he served as the head of the Department of Naval Architecture, Ocean and Marine Engineering, and associate principal and the executive dean of the Faculty of Engineering. Besides, he was a research manager of an industrial doctoral center for offshore renewable energy and is a chair professor at Zhejiang University. His research activities include the development of hydrodynamic design and analysis tools and model testing of marine and offshore engineering systems, including marine renewable energy devices. Today we have two platforms. As usual, we have Zoom and also WeChat platform. If you have any question, if you use Zoom, you can use the raise your hands button. If you use WeChat platform, you can leave your question in the chat box on the screen. Okay, then let's start. Professor Incecik, over to you. Now you can share your screen.
Okay, thank you very much indeed, Professor Shu. First of all, for very kind introduction, but also for inviting me to give this webinar this afternoon. So I'm very pleased to be able to connect through these two platforms and then share some of my thoughts with you. And so with that, I'm going now to try to share my screen and hope that it will work. And if let me know if you don't see it. So on my screen, I can see it. Can you also see the screen? Can you see my presentation?
Yes.
Yes, excellent. So, and okay. And then I can perhaps make this bit larger. Yeah. And still okay?
Yes, very clear.
Okay, great. Thank you very much. So as Professor go up to 8.5 billion within the next 6-7 years or so. And with that increase, also will be increase of people will be moving to the urban areas. So therefore, a lot of population will be concentrating, for example, along the coastlines, etc. Obviously, as the world population will increase, the demand for water, both for obviously drinking, but also for industrial use, will increase. So, and that will, of course, then will put pressure on the water supply for agricultural purposes. And then, of course, that will then put pressure on food production. So, and also, of course, all nations more and more aware of the health, safety, and security aspects, and therefore people working particularly in the industry, and they will be looking for more healthy and safety environment, and therefore this is going to be now the introduction of much more stricter regulations, and that regulations will also, of course, be applicable to the waterborne industries. So, in terms of economical aspects, obviously the countries in Europe, in United States, etc., they will have either steady grow or very constant progress in terms of the GDP developments, whilst in countries like yours and also in India, the predictions are for the GDP to reach a double figure between during the period of 15 years from now until 2030. So, and of course, as I said earlier, the increasing population will naturally then put demand not only on water supplies and also stricter regulations on health and safety aspects, but also demand on energy. So we are expecting that between now and 2020, again, will be energy production growth at about 1.5% per annum. And most of the, again, demand will come from the Asia-Pacific region. And of course, will be still, as I show you in the next slide, demand for oil and gas and coal, whilst also other renewable energy sources will continue to be developing. And this is the graph that obtained from one of the oil companies' website, showing their predictions, how they change in the energy, primary energy use by different fuel types. As you see here, green is showing the oil, and red is the gas and coal and nuclear, hydro, and renewables. So during the next 20 years or so, obviously will be steady demand or use for oil, and little increase in natural gas, and again steady demand for coal, and then of course increasing use of the renewables, whilst little increase also in hydro, but nuclear also will be more or less constant, as I predicted. However, when we look at the percentages, as you will see, as I mentioned also in the earlier slide, still coal, oil, and gas will provide significant amount of the energy supply, as you see here, whilst of course the oil use will decrease and the gas will increase. But between these two, they will actually provide about 50% of our needs. And of course, another 20% will come from coal. Therefore, between now and until 2040, in other words, roughly within the next 40 years or so, still predictions are that energy supply will come from oil, gas, and also coal at a level of about 70%. Of course, oil and gas will have equal share, almost. So that's how these predictions show for the primary energy use. Now, of course, waterborne trade will also continue growing with economic growth, and whilst, of course, all this happening, already we feel that there is a change in climate. We definitely feel in various parts of the world and unusual, temperatures, and again, rainfalls, and then frequent storms, and then obviously, we were reported that polar ice melting continues. So, of course, these are all going to have effect on, waterborne operations. Now, we are all aware that huge advance in the computation capacity, data storage capabilities, and how we can access to the network. And like, for example, today, we are very, easily connecting, miles away from each other, and and then you can see me, you can hear me, and this is all thanks to the, advancement in the IT technologies that will, of course, will continue advancing, and all these will also have huge impact on digitalization of our sector. Okay, so we also summarize the waterborne aspects in terms of effect on the, waterborne transportation as the population increases. So what will then happen is that increasing urbanization, as I said, as the population increases, people will want to move to the urban areas, including the coastal areas in particular. And this will lead to new and upgraded port infrastructure. And of course, this port infrastructure also will be required now with the introduction of alternative fuels. And we are talking about, hydrogen, we are talking about ammonia, we are talking about, LNG, and of course, they all require, upgrading of the port infrastructure to supply these fuels. And then, of course, as the population goes up, number of ships will naturally increase, and particularly ferries that transporting people from A to B. Also, cruise ships, people obviously, as the wealth grows and they spend a lot of time, with their leisure activities, and as well as, of course, other leisure sporting activities. So now, demand on food and water supply will give rise to transport of fresh water, transport of food production at sea. This is particularly important, of course, again, in the coastal areas, fish farming and aqua farming. And again, in order to provide water in areas that not, enough rainfall, therefore you need to, in fact, or any rainfall, therefore you need to desalinate seawater to produce fresh water. And these are all, of course, will require, specialized infrastructure. And as I mentioned earlier, there's increasing awareness of health and safety and security amongst the people working in our discipline area, but also, of course, in general, people working in industry. Therefore, more and more strict safety and security standards are introduced. Now, as we know, as I also indicate in the next slide, there is huge, very ambitious targets are set to reduce the greenhouse gas emissions. GHG, as you know, means greenhouse gas emissions, and these requirements or limitations on the emissions will require reduction of energy consumption through the introduction of new technologies, which I will mention in a minute, and then use of cleaner fuels. Again, I mentioned earlier, like LNG, ammonia, methanol, hydrogen, and hybrid solutions. And we could also, of course, include there in the near future also nuclear fuel to provide, propulsion for the marine vessels. But whilst all these new fuels are introduced, what is really very important is that we train people on board the vessels using, if you like, these fuels for their safe operations. And the other thing that's happening, of course, increasing the electrification of ships. And again, as mentioned earlier, all these new fuels require the modifications in the port infrastructure for bunkering purposes. Now, the systems that are being considered or are applied today to reduce greenhouse gas emissions through decreasing ships' resistance includes the following technologies. One is already applied in various, ship designs, is the air lubrication system. Basically, this is to create a carpet of micro bubbles on the bottom of the vessel, so that these micro bubbles reduces the frictional resistance, of the ships. Therefore, saves fuel, and hence reduces the greenhouse gas emissions. The other concept that is being studied and tested in full scale is the gate rudder concept. This is an innovative energy saving and maneuvering device, and basically it consists of two foils on either side of the propeller. The foils are expected to improve the propulsion efficiency and therefore reduce emissions. And the other technology that are applied are the rotor sails. These are basically, rotating cylinders attached to the deck of the vessel, and they will then harness the wind energy to provide additional propulsion to a ship. And they are used for new build as well as retrofit designs for any kind of vessel, basically. And the other technology that uses the energy saving propeller cup. And again, that is the cup that you add to the propeller boss, and to improve the propulsion efficiency, and again provide full fuel saving. Oops, sorry. And so the other technology is the integrated propeller and rudder design, and again, this will increase the propulsion efficiency and improve the maneuverability of ships. And the other technology that are being developed is the smart control system that combines optimal propeller pitch with optimal energy loading. And so again, this is with a view to reducing fuel consumption and basically make use of the fuel at the most optimum level. And finally, the system that again has been studied to see its feasibility is actually adding carbon capture and storage system on board ships. Of course, today these systems are operating on land to capture CO2 from the industrial factories and other CO2 generating establishments, and then they are of course captured and then stored either under the seabed or basically pumped into the oceans, to disintegrate. So these are actually already applications on land. And then, of course, if they are, pumped back into the oil reservoirs, they will not only serve the purpose of storing there, but also increasing the basically return of oil and gas recovery. Basically, they will enhance the recovery rate of the oil and gas. So it is very well established technology, but that is now being considered for applications on board ships. These are all to reduce the greenhouse gas emissions from ship operations. So now obviously, every day we hear that more and more regulations are introduced either by IMO or by governments to again reduce the environmental impact from shipping operations and offshore activities, including renewable energy, and also obviously much stricter emission control in port areas, because as you know, obviously huge amount of ships enter into the port areas and make sure that they have, they obey certain restrictions in terms of how much they can operate their engines. Ideally, of course, they then have connection to the electric supply to use the electricity rather than burning oil or LNG or whatever on ports. But also, of course, make sure that there is a optimum, if you like, traffic control system to ensure that ships do not, spend they introduce more ambitious targets to reduce the greenhouse gas emissions. That is basically by 2050, the regulations or the recommendations are that ships should reduce no greenhouse gas, and there are going to be also checkpoints, and by 2030 they want this, the greenhouse gas emissions to reduce by 20% compared to the figures in 2008, and by 2040 that will need to be 70% at least, and ideally 80%, and again compared to the figures in 2008. So really, these are very ambitious targets introduced by the IMO, so that we then obviously work very actively on new fuels, on technologies, as I mentioned before, to reduce the greenhouse gas emissions. Now, the other thing that, of course, in terms of the renewable energy area, these devices, whether it's wave energy or tidal or wind, either during construction or during operation, they generate a lot of noise, and this noise, of course, will have adverse impacts on the marine animals, and therefore there are requirements how we can actually tackle with this challenge, with this problem. That requires improved monitoring of the noise levels and improving the methods that enables us to predict how the noise propagate in water, particularly in polar areas. And because with the climate change, the shipping may shift more and more to polar areas, and then developing regulations to limit the noise levels and then obviously we need to understand how the effect of noise generated by vessels will actually have effect on marine life. So that is basically all about improved monitoring, data collection, and wildlife proximity technologies. Therefore, this is to really understand the animals, marine animals' behaviors, and then of course also we need to work on the technology side to improve the ship hull design and propulsion systems for generation of lower noise and without economical penalties, and then finally, of course, really we need to work with our marine science colleagues to really understand the marine animals' behaviors under when there is at various levels of noise. So that's really one of the, again, there are recommendations by IMO, which was introduced some years ago, and they are now required to be updated again. So coming back to, again, economic growth, and that's naturally will require increased transport of goods because, as people becomes wealthier and they want to have several, televisions and all the other gadgetry, and then of course demand on energy and raw materials, and people then will require more fresh water, and we need to harvest the raw materials offshore, and again that will require significant investment in new port facilities. And energy demand, again, require an increase in the renewable energy devices, utilization of renewable energy devices, and then significant increase in production of and transport of clean fuels like LNG, shale gas, hydrogen, etc. And again, because the oil and gas dependence will continue, we need to continue exploring reserves in deep water areas, and we need to continue developing port infrastructures for offloading the produce oil and gas, etc. And so waterborne trade growth will lead to increase in port activities, port congestions. Increasing ship size will lead to port extensions. Alternative fuel trade leads to transport of LNG, methanol, ammonia, and hydrogen. And also, of course, we need to make sure that we are prepared for bunkering of alternative fuels. And as we were discussing earlier, climate change will lead to more flooding and extreme weather events, and polar melting will impact all on waterborne sectors. And so naturally, as the climate becomes more severe, we need to have, ships are designed and built at the required strength, and similarly, and also ports and offshore structures to cope with the severe weather conditions. And then we need to apply more and more actively weather routing. And as the weather becomes severe and severe in the open oceans, we may need to use more Arctic routes. And then again, because of the conditions are more calmer in the Arctic areas, and then we need to require to produce fossil fuels in the Arctic areas, and then we have to make sure that coastal areas are protected with dikes and ship fairways, etc. Again for flooding. Now, ICT developments obviously will, result in higher degree of automation, and that will then help the sea and shore-based operations integration. And we make sure that obviously the ICT systems are protected against cyber attacks, and obviously the storing electronic data much better than paper documentation. That will obviously not only save space, but also it will be easier to complete on a computer. And however, we have to make sure that the data on digitalization of data are properly protected, using the intellectual property rights, etc. Now, last couple of slides, I will emphasize the importance of the education. As all these, we talked about all the new technologies, new fuels, new research areas for developing these new technologies, etc. Of course, require continuous training of people, and also obviously, just a minute. Selam. Şu anda Çin'e ders veriyorum. Ben seni sonra ederim. Okay. Tamam. Görüşürüz. I'm very sorry. Okay, so obviously we need to make sure that our training and education for the new technologies, for the new fuels, for all the new ICT systems are also brought to our undergraduate MSc and of course PhD levels, so that really the new concepts, new ideas are taught, but also are effectively and safely applied in marine technology, in marine applications. So this really requires, of course, also importance of the continuous professional development, and because obviously people working on board vessels, they need to be retrained how to use the new fuels. They need to be retrained how to use all the computerized systems. And this is absolutely important for the safety of the crew on board, but also, of course, safety of the vessels. And we also need to continue promoting our field to attract very high caliber, if you like, students, high caliber talent to enter into the naval architecture, ocean and marine engineering area. And so this is a crowded slide, but basically really summarizing again what I was saying in terms of the, professional continuous development. Of course, people working on board vessels, you will not be able to take them away from their day jobs. So really, we can use e-learning or distance learning programs to train or retrain, upskill personnel at work, so that it actually can apply at every level. That not only applies to people working on board vessels, but also, people working at universities. So, obviously, some of these new technologies may be introduced through new MSc programs, etc., but not everybody will be able to attend these courses. However, if you introduce such courses through e-learning, and of course the uptake will be much higher, and therefore will be much effective way of actually reaching out to people that need to be retrained not only in the use of new technologies, but also in developing these technologies. So really, education and training is absolutely important for the future developments. So I'm nearly coming to the end of my presentation. And then, of course, afterwards, I'll be very pleased to answer your questions. But all I want to say is that the power of education, research, and innovation, and of collaboration globally will enable us successfully address the marine technologies challenges that I described above. So with that, may I thank you very much for listening to me, and once again to Professor Xu inviting me to deliver this lecture. Thank you very much.
Thank you.